So we are starting index laws now. In this booklet, we're just going to be covering this very first dot point of the algebraic techniques part of the syllabus. So we're just going to be doing that dot point, and we're going to go through and cover as much as we can of that today, and then everything else that we don't cover today will be part of next lesson. Alrighty? Alright, now, the first thing I want to talk to you guys about is what is an index law and what is an indice. If I spelled indice wrong, it's not English class, I'm sorry. So, couple of things here, guys. In school, when they teach you this, they conveniently skip over the main part of this topic, which is telling you what indices even are. So you guys all in your head think, oh, well, I already know what an indice is. It's just something like 5 to the power of 2. That's an indice. But you don't think about what that means. And what they do at school is they just start telling you all the laws. Oh, you can do this when you have this. You can do this when you have this. And they don't tell you what they're talking about from a mathematical viewpoint. And then students start to get really, really confused. I'm going to the best of my ability, try and clear that confusion. But you have to listen very carefully to what I'm about to say. And what I'm going to say here is that this whole topic, this entire topic, is just a multiplication topic. That's it. Okay? Haven't we already learned about multiplication? Yeah, we have. So remember, when I say multiplication, I also am talking about division. So I'm talking about multiplication and division. But that's not a very new concept to you guys. You guys already know about multiplication. We've already learnt this as part of very, very basic algebra. We already know that if I take a times a, that equals a squared. If I have something like a squared plus a squared, that's 2a squared. We know that if I have a squared plus a cubed, that's a squared plus a cubed. I can't do anything there. We already know all of these things. This whole index laws topic is just rehashing this to you, but using these fancy formulas that you've never seen before, and it does start to really confuse students. I want you guys in your head to think to yourself, I need no fancy formulas. You don't need formulas. These formulas that they're going to introduce to you at school are not on your formula sheet. You will not have the index laws on your formula sheet. What does that mean for you? That if you want to do this whole topic by using formulas, you're going to have to rote memorize all the formulas. And we know in my class we're very against rote memorization. We don't do it, okay? So it's all about understanding what an indice is. So let's talk about what I mean by this. So entire topic is about multiplication, and what is an indice? That's what we want to start with. So we realized in math that we had to multiply the same number together quite often, okay? For example, when I'm finding the volume of, I don't know, a cube. When I find the volume of a cube, like this, let's say this is the cube, and I'm going to say, well, this cube represents a swimming pool, and it's a ginormous swimming pool for, I don't know, hippos. I don't know. Let's say I'm a zoo designer and I'm making a swimming pool for hippos. I'm sure someone's done that. Let's say that because it's such a huge swimming pool, the meters is something like this, 10 to the 4 meters. And then because it is a cube, all of it will be the same. So 2.63 times 10 to the 4 meters. Don't quote me on the size. It might be too big or too small for a hippo. I don't know. Okay. But moral of the story, it's an annoying number to write down. That's what I'm trying to get at here. Now, how can I calculate the volume of a cube, Andrew? How do I find the volume of a cube? Times all the sides together, yeah? Exactly. So I'm going to do 2.63 times 10 to the 4 times 2.63 times 10 to the 4 times 2.63 times 10 to the 4 meters cubed. Now, we had to multiply the same number together 3 times. And that's fine. Not incorrect. We can do that. But we noticed this problem popping up a lot in math. We noticed that it didn't only happen when we were finding volume. It happened in a bunch of other places, and we realized, we're multiplying the same number together all the time. Why don't we just come up with a shorter way to write that? Because we can't be bothered writing the same number over and over and over again. If any of you guys have ever done coding before, you would know that instead of writing the number 3 everywhere, if we use the number 3 a lot, we just make a variable. And we call the variable number 3. And we make it equal to 3, and then we use the variable everywhere instead of the number. So if we want to change the number, or we want to use the number in lots of different places, we have a little nice variable to use for it, okay? We don't like to rewrite the same number over and over and over again. It just gets really messy, really confusing, okay? So mathematicians at the end of the day said, okay, we need to multiply the same number together way too often. So screw it, let's just come up with a short way to write it down. Instead of multiplying the same number over and over, let's come up with a shorter way to do it, because we can't be bothered doing this. So they came up with a notation. So instead of multiplying the same number together multiple times, mathematicians came up with a shorter way to write something like that down. And the shorter way, I'm sure you guys all know it, is to take the number you want to multiply. So I want to multiply 2.63 times 10 to the 4. I want to multiply that number by itself 3 times. So I'm just going to pop it into brackets, and I'm just going to put it to the power of 3. And that's the same thing as multiplying it by itself 3 times. So what are indices? It's just what I like to call a shorthand way. When I say shorthand, that just means a shorter way to write multiplication of the same number. That's it. That is all indices are. So then the question, what is an index law? We came up with all these really fancy laws so that instead of every time you get something like this and I ask you to simplify it, instead of you simplifying it, you just know all these like fancy rules that you can do. For example, there's the power rule where you can expand a power into brackets. But we're not going to focus on those laws in this class, and what we're going to focus on instead is understanding where those laws come from so that they just come naturally to you, okay? So, now that we understand what an indice is, so to make this extra clear, indices are just a very shorthand way to multiply the same number together over and over and over and over again, okay? So now let's then move on and let's look at the different ways we can use indices with algebra. Before we start, I would like to say, when I introduce this topic to students, normally around year 8 level, a lot of them ask me, oh, Marianne, can I do this with indices? Can I do this with indices? And my answer to them is always, don't ask me. Just think about, can you do that with multiplication? If you can, then you can do it with indices, because indices is just multiplication, okay? So I don't want you guys to think it's anything special. It is literally at the core of it, just multiplication. That's all it is, okay? Don't think it's anything else. Alrighty, so we're going to now think about multiplying numbers with indices. Now, I'm going to try and teach this to you in the most intuitive way possible. I don't want to introduce any new concepts to you. I literally just want to show you what you already know about this, because believe it or not, you already know this whole topic. It's just me rehashing things and putting them into a new form. So let's look at, can we multiply? Can we come up with a way to nicely multiply, and I'm going to say nicely and quickly, multiply numbers that have indices? Now, I don't want you guys to copy anything down. I literally just want you guys to stop and listen. This part is very important. I've put down a bunch of different types of multiplication with indices, okay? We're going to try and figure out which ones we can do and which ones we can't do, and then I want you guys to see if you can tell me what the pattern is. Let's start with this one. Very simple, very easy. We're going to start by expanding every single time. So Chris, can you expand the first number for me?
2 times 2 times 2.
Good. So instead of 2 cubed, we spoke about this in the last page, but we did say that it is the same as just multiplying the same number by itself 3 times. So that's all we've done there. Then Andrew, can you give me the second number?
2 times 2 times 2 times 2.
Beautiful. And then can I get Ava, can you tell me how many total times am I multiplying 2 by itself?
7.
Beautiful. So I can just change it, instead of 2 times 2 times 2 times 2 times 2 times 2 times 2, I can just write 2 times 7. And we spoke about this in the last page. Everybody agrees with that, yes? Let's go through the next one. Layla, what's the first number? Expanded.
2 times 2 times 2.
Chris, the second one.
3 times 3.
Cool. Now, Andrew, can you simplify this for me, keeping in mind that I only want you to simplify with indices. So if you have the same number being multiplied, you can raise it to a power. But if you don't multiply like 2 and 3 together. So only just, if there's like 2 times 2 times 2, just tell me it's 2 cubed. So what do you think?
It's the same as the beginning.
It's the same as the start. So it's just 2 cubed times 3 cubed. Nothing changed. 2 cubed times 3 squared. Nothing changed. Interesting. So something changed here, but nothing changed here. Let's keep going. This one. Ava, the first one, please.
8 times 8 times 8 times 8.
Cool. And then Layla, the second.
B times B times B.
And then Chris, the final product.
Would just be the same.
Same thing. Okay. Cool. Interesting. Cool. You notice that the only thing that did change is I just removed the multiplication symbol, because remember with algebra, if you have letters being multiplied, you can just glue them together. That's the only thing I changed, but essentially it's the same thing as the start. Okay, weird, because the first one changed. Let's see what happens here. Andrew, first one?
8 to the power of 4. No,
Yeah, exactly, a to the power of 4. Cool, so the left one becomes a times a, the right one becomes a times a, and so we just end up with a to the power of 4. Okay, this one's changed. Let's do the last two. I think by now you guys already know what the pattern is, but let's just do it for the sake of it. So Layla, this one please.
C times C.
And then?
3 times 3.
And then?
C squared times 3 squared.
Yeah, so it's just 3 squared c squared. That's it. And then Ava, I'll just get you to quickly go through the last one, please.
C times C.
Yep.
Times B times B.
Yep. And then I get?
The same.
Yeah, c squared b squared. Now, can I please get Andrew? What's the pattern here? When can I do something, and then when can I not do that thing?
You can do when they have the same.
Do what? Can you tell me what the something is?
Add the powers together.
Yeah, cool. So you guys noticed that when, now what was it, Andrew? When what?
When they have the same, basically, denominator.
Yeah, you can call it a denominator. It's actually called a base number. So the big number at the bottom is called the base, and then the small number at the top is called the power, just so you guys know. Now, what Andrew has just told us is when the base number is the same, we end up just adding the powers together. And that should be very clear to you why that is. Because at the end of the day, it's just like saying, okay, we multiply 2 by itself 3 times, and then we multiply it by itself 4 times. So in total, we multiply 2 by itself 7 times. That's so obvious. But if I multiply a by itself 4 times and b by itself 3 times, well, I just multiplied a by itself 4 times and b by itself 3 times. There's nothing I can change there. Okay? So this brings light to the first index law. And the index law is, if you have two numbers with the same power, the same base but different powers being multiplied together, the index law is a equals b plus c. That's the first index law they're going to teach you at school. Now, the only reason I'm showing you this, I don't like showing people the index laws. I don't think they're useful to know. I think it's more useful to understand where they come from. But the only reason I'm showing it to you is so that when you see it at school, you're not like, what the hell is that? Okay? So that index law says the same thing as what we set up here. Okay? So I'm just going to write a little note here that I don't want you guys to try and memorize this index law. Does everyone agree that this is very obvious? Yeah? It's so obvious. If the powers are different but the bases are the same, you can add the powers together if the base is the same. If the base is not the same, you cannot add the powers together. That is very obvious because we all understand multiplication in this room. Yeah? So I'll write that down for you guys. Now, the reason I don't like the way they teach this at school, guys, is just because, imagine I just showed you this and I said, okay, Guys, this is the index law that you need. This is the multiplication law. Do you think you'd have the same understanding as if I did all of this? Probably not. You'd be like, what on earth is that? Okay? But really all this is saying is if you multiply A by itself B number of times, and you multiply A by itself C number of times, then you multiply it a total of B plus C times. Okay? And I think from these examples with real numbers that it does make a little bit more sense. Yeah? So when you see this at school, don't think of this, because if you guys try and remember this, I promise you, you're gonna confuse yourself because there's a lot more index laws to come. I don't want you to try and memorize this. I just want you to understand this. And if you understand this, this should be very obvious to you. Okay? So let's do a couple of questions here, and then we're gonna stop there for today. My hint here is if you're not sure about something, expand it in the same way that we did in the previous parts. And my second hint is BODMAS, BODMAS, BODMAS. Be careful when there is addition and multiplication mixed in the same question. My first step is always to put brackets around the things I need to do first. For example, remember you should do multiplication before you do addition. So you should put brackets around all the multiplication. Okay? Be very careful because a lot of students lose marks in indices because they don't know BODMAS well. So just answer these questions and then we'll be done for the day. So to go through these questions, the first one. I like to split it up into multiplying numbers and letters separately. So I'm going to rewrite it as 2 times a cubed. And so I just get 2 times a to the 4, which is just 2a to the 4. Does everybody understand that one? Yeah? So notice I multiply a times a, which is 4a's, and then 2 just stays at the front. The next one. As I said, you should put brackets around the multiplication because you should do it first. So this first one I get a to the 7. The second one I get 3a to the 7. And so from algebra you should know that a to the 7 plus 3a to the 7 is 4a to the 7. Okay? So now we're mixing indices with algebra. The next one. Again, as I said, I like to put the numbers and the letters together. So I'm going to do 4 times 3 times 2 times a times a times a. So I get 4 times 3 is 12 times 2 is 24, and then a cubed. And then the last one I have here, 5a squared. Now this one's a little confusing, but not too bad. I have this whole thing in brackets squared. So you're squaring the bracket itself. So I have 5a squared times 5a squared. And that gives me 25a squared. You can also have a step in between where you have 5 squared a squared. So if you have 5 squared a squared, just don't forget whenever you have a number squared, I know we didn't do that in this page, but as a general rule, when you have a number squared, you should always plug it into your calculator, or if you already know the answer, you already know the answer. So we know that 5 squared is 25, so you should just write 25, okay? So that's everything you need to know about multiplying indices. Then we're going to move on to other types of questions next week. We'll look at dividing indices, and then we'll also look at more questions like this, which is like a power of a power. And then we'll look at weird things like fractional indices, and also we'll look at things like what happens if I raise 5 to the power of 0? What does that even mean? How do you multiply a number by itself 0 times? Doesn't really make sense, and I'll give you a hint, the answer is not 0. The answer is 1. So then that kind of makes you say, how does multiplying 5 by itself 0 times give you 1? What the heck? So we'll go through that all next week, and we should have finished indices by next week. Alrighty, guys. I'll see you guys next week.